Hi friends, in our last session we have started with design procedure of multi-speed gearbox. In that we have completed till determining the structural formula, that is how we need to form a structural formula. In today's session we will study how to draw a structural diagram, and from that how to draw a ray diagram and a speed chart. This is Faizan Kagzi and I welcome you all to our lecture series of machine tool design. So let's begin. Now, structural diagram. So what is that? So we would say that a structural formula represented by a spatial graph, that graph is called a structural diagram. It is basically a German layout. Now let us understand that how it is represented and how we need to draw it. Okay, so the first step to draw a structural diagram is that draw Z number of horizontal lines that represents the total speeds, which means over here in this diagram you can see that I have drawn horizontal lines. So this horizontal lines is equal to the number of speed steps, which means that if we have a 6-speed gearbox, then we need to draw a 6 horizontal lines. Okay, so that is going to represent the speeds n1, n2, n3, n4, n5 and n6. Okay, similarly we need to draw n plus 1 number of vertical lines, so it represents the total shafts, which means you can see that I have shown 3 vertical lines over here. First vertical line, second and third. The first vertical line in this diagram represents the input shaft. Okay. The second vertical line in this diagram represents the intermediate shaft, and the third vertical line represents the output shaft. So in this diagram you can clearly observe that it has two stages. Okay, so this space between these two lines represents stage 1 and this is representing a stage 2. Okay, so n plus 1 means first vertical line, second vertical line and third vertical line. Okay, remember that these vertical lines represents total shafts. Okay, now third point to draw this, distance between two horizontal lines is has to be kept equal to log phi to the base 10, which means you can see the distance between these two lines we are going to consider log phi to the base 10. But in a general way, whenever we draw this diagram, so we need to draw it a random way, but just mention that the distance will be how much, so we are going to write log phi to the base 10. Okay, so this first stage over here you can see I have written P1 x1, and the second stage over here I have written P2 x2, representing a first transmission group, and this represents a second transmission group. Now consider a case of a 4-speed gearbox. So for that we can say Z is equal to 4. Okay. Now Z is equal to 4. We can break this equation in our case of a structural formula. So it is going to become what? 2 into 2 2. So this is our structural formula for a 4-speed gearbox. Okay. Now from this, can I say that it would have two stages? How it is having a two stages? So we would say 2 raised to 1 into 2 raised to 1. So total how many? So 1 plus 1 is 2. Okay, so n is equal to 2 over here I have written. Now by using this concept, can I say the horizontal line which we need to draw is 4. Okay, so this horizontal line is going to represent the number of speeds available, and vertical line should be how much? So we would say 3 vertical lines. Why 3? Because over here there are 2 stages, so we need to draw 2 plus 1, which means 3 vertical lines. So over here you can see in this diagram, the first vertical line represents the input shaft, second represents intermediate shaft, and the third one represents the output shaft. Okay, now in between this space is called our stage. So this is our first stage between the two shaft. This is the second stage between the intermediate shaft and output shaft. Okay, so in between this we have to write this formula. So 2 1 into 2 2. So over here you can see I have written 2 1, and over here in this stage I have written 2 2. Since we know that in a first stage two speed steps are available, from this equation we can clearly say that two speed steps are available, but at a distance of how much? So you would say at a distance of 1. So over here you have to mention that it is a first node point, node 1, node 2, node 3 and node 4. Okay, so whenever there are 4 nodes, so we need to select a in between position, that is a median position to start to draw the diagram. So over here you can see this is a median position which I have selected. Now from this position you have to draw two straight lines connecting input shaft and output shaft. So this represents the one of the speed transmitted, this represents second speed transmitted. Now these two speeds are separated by how much distance? So 1. So over here you can see I have kept a gap of 1 unit. Okay, so over here you can clearly see 2 1, which means two lines are drawn and at a distance of how much? So 1 unit. Okay, now from this point over here you can see in this stage 2 2, which means two speed steps are there and we need to keep a distance of 2 units between a two speed steps, which means from this point again we need to draw two lines. So from this point over here you can see one line is going in a upward direction and second line is going in a downward direction. But how much is the distance between these two lines? So we would say 2 units. Okay, so you can see this is 1 unit and this is the second unit between these two lines. Similarly, from this point of an intermediate shaft, can I say again two speed steps can be obtained. So we need to draw two lines. So from here it is going to move in this direction, this point, and second in a downward direction. So you can clearly see the distance between these two lines is how much? So it is 2 unit. So this represents x, which is over here 2. Okay guys, so I hope that you are clear that how we need to draw a structural diagram. Now let us proceed further. Considering another case to understand this, I am taking a 6-speed gearbox. Okay, so you can clearly see the equation will become z is equal to 3 into 2, 3 2s are 6, right? Now in first we know that we are going to take x1 equals to 1. So over here I have taken 1 and x2 should be how much? So x2 will be equal to p1. Okay, so p1 is what? So p1 over here is 3. So z is equal to 3 1 into 2 3. Now how many horizontal lines we need to draw? So we know HL is equal to number of speed steps. Okay, so that is how much? 6. Okay, and how many vertical lines? So we know it is equal to n plus 1, which means n is how much? So we would say it is a 2 stage. Okay, 3 raised to 1. Remember, if you remember, we have discussed last time, that is number of stages capital N is equal to n1 plus n2. So from this equation we can clearly say that 3 raised to 1 into 2 raised to 1. So n1 plus n2 is how much? So n1 plus n2 is 2. Okay, so over here n is 2 and vertical lines n plus 1, which means total would be 3. Okay, now over here you can clearly see I have shown stepwise. So first I have mentioned at the bottom side, that is n1, n2, n3, n4, n5, n6. Okay guys, the distance between two horizontal is how much? Log 5 to the base 10. Now over here I have written 3 1, that is the first stage, and 2 3 second stage. So we need to see the median position. So median is between n4 and n3. So I have selected this point. Now from this point, see carefully that how many lines are there. So we need to draw 3 lines. That is a 3 speed steps. So one of the speed step would be straight horizontal. So first line will be a horizontal line representing that same speed is transmitted. But how many lines we need to draw? So we need to draw 3 lines, that is representing a 3 speed steps. So at a distance of 1 unit we need to draw another line. So from this point how much is a 1 unit? So over here, okay, so in the next diagram you can clearly see I have mentioned over here, that is a second line will be drawn, and similarly at a distance of 1 unit from a median position another third line will be drawn. So this represents the 3 speed steps are available in our first stage. Okay, now going into a second stage. So for second stage how many speed steps are available? So we would say 2 speed steps, but 2 speed steps are separated by 3 units distance, Okay guys, so see this diagram. In this diagram it is represented by a blue line. So from this point how many speed steps? So 2 speed steps represented by this blue line. Okay, but at how much distance we need to keep this line? So at a distance of 3 units. So one box, second box and third box. Okay, clear guys? Similarly, can I say that from this point again two speeds will be available? So over here you can clearly see that from this point two speed steps are two blue lines are drawn at how much distance? So at a distance of 3 units. So 1 2 and 3. Similarly, from this point again we can draw two speed steps, right? So over here you can clearly see that first and second blue line, and both these lines are at a distance of how many units? 3 units. So in this way we can draw a structural diagram of a 6-speed gearbox. I hope that you are clear with this diagram. Okay, now let's proceed further. So features of structural diagram. So let us discuss that. We can say that information given by the structural diagram is that number of shafts in a gearbox are how much. Okay, so from this diagram you can clearly see that we can determine the number of shaft, that is first represents the input shaft, second represents the intermediate shaft, and the third line represents the output shaft. Similarly, we can say that number of gears which are present in a gearbox can be easily determined. Now how we can do that? So we can say that that is one line of this represents one gear pair, second line represents a second gear pair, and third line represents a third gear pair. Okay, so we can clearly say that over here there are 3 gear pairs available. Similarly, from this diagram we can clearly say that over here there are how many gear pairs? So over here 2 gear pairs will be available in matching with each of this structural diagram. So from this we can say that number of gears on each shaft can be determined. Even there is one of the formula to determine the total number of gears which are present inside a gearbox. So the formula is that G is equal to 2 in a bracket P1 plus P2 plus P3 plus up to Pn. So if there are 2 stages, so we can say that it would be 2 into bracket P1 plus P2. Okay, next information given is transmission range of each transmission group can be easily determined. Now information which is not given is spindle speed is how much, range ratio of a spindle speed is how much, motor speed is how much, and geometric progression ratio is how much. So we can clearly say that this information is not given. Now for determining this information, that is motor speed is how much, range ratio is how much, spindle speeds are how much, so we need to draw another diagram. So that diagram is called a speed diagram and a ray diagram. Okay, so let's proceed further to draw that diagram. Now the next step in a design procedure is first we need to select the optimum structural diagram. So the criteria for selecting optimum diagram is first transmission range restriction, which means there is a formula that is Ig stage has to be equal to phi raised to p minus 1 into x. Now this equation where phi represents the geometric progression ratio, p represents the speed steps in each stage. Okay, p represents speed steps in a stage, minus 1 in a bracket x. Now x represents the distance by which two adjacent speed steps are separated. So this is a formula which we need to keep in mind to determine a transmission restriction, and this value should always be less than 8 in order to obtain an optimal structure diagram. Now next, there is a node method of optimization. Now that is basically it represents that we require a minimum size of diameter, okay, to transmit a maximum amount of power. So that method is represented by a node method of optimization. So the node is a point from which a ray starts or at which the ray terminates. So select that structural diagram which has higher number of nodes. Okay, next point, important point for selecting is minimum number of gears should be provided on an output shaft. So this is the most important criteria. Remember, whenever we design a structural diagram, we need to keep in mind that there should be minimum number of gears on the output shaft. It is preferable to keep 2 gear pairs on a output shaft. Okay, so now next point, maximum speed ratio in a last stage should be available. So this means that x1 should be less than x2, x2 should be less than x3, and so on. So obviously we clearly know that x1 is how much, we always take it is equal to 1. x2 is how much, so we take x2 is equal to p1. x3 is equal to p1 into p2. Okay, so these are the criteria which we need to keep in mind for selecting the optimum structural diagram. Next, we need to construct a ray diagram and a speed diagram. Now, the structural diagram, why we need to construct this? So we can say that a structural diagram can neither give us spindle speeds nor it provides a range ratio of a spindle speeds. Also, it does not show the motor speed. So these are the disadvantage of a structural diagram. These informations are not given. So for determining these parameters, we need to construct a ray diagram and a speed diagram. So let's proceed further. How to draw a ray diagram? Now, in this, while drawing a ray diagram, we need to keep in mind that vertical lines should be equal to n plus 2. So n is what? N is a number of stages. So n plus 2 should be the vertical lines, and horizontal line should be how much? So horizontal line should be equal to z if last speed of a gearbox, that is the maximum speed of a gearbox, is greater than motor speed, that is NEM means motor speed. Okay, and if motor speed is greater than the maximum speed of a gearbox, so how many horizontal lines we need to draw? So we would say HL is equals to Z plus 1. So these are the points which we need to keep in mind while drawing a ray diagram. Okay, so remember, vertical line should be equal to N plus 2, horizontal line should be is equal to Z if maximum speed of a gearbox is greater than NEM, that is motor speed, and it has to be Z plus 1 if motor speed is greater than the maximum speed of a gearbox. Now, what is the main difference between a ray diagram and a speed diagram? So we can say that in a ray diagram, it depicts the transmission between a last stage, a last shaft and a preceding shaft. Okay, and the rays are drawn for the lowest RPM of the last shaft. So you can clearly see in this graph represents a ray diagram in which a lowest RPM of a last shaft is represented. Last shaft means our output shaft, and the lowest RPM of this output shaft is what? So we would say N1, which is N minimum. So this is represented by the rays, that is a ray diagram. Okay, now what is the difference? So over here you can clearly see that the number of vertical lines are how much? So you would say N plus 2, which means the first line represents the motor shaft. Okay, motor shaft. Second line represents the input shaft, which was similar with the structural diagram. Third line represents the intermediate shaft, and a fourth one represents the output shaft. So remember that this has to be N plus 2. Okay guys, N plus 2. The first line will always represent motor shaft line, which has to be included in our speed diagram, similarly in a ray diagram. Whereas this line will not be present, motor shaft line will not be present in case of a structural diagram. Why? Because structural diagram just represents the structure of a gearbox. Okay guys, and speed chart going to represent the entire speed which is provided to the gearbox starting from a motor, that is motor shaft. Okay, now let us see this diagram. So over here I have considered this case, that is HL is equal to Z plus 1. In this I am considering that motor speed is greater than the maximum speed of my gearbox, which means you can clearly see that the horizontal lines which I have drawn is equal to Z plus 1. Okay, the speeds available are how much? 6 speeds are available. Okay, that is a 6-speed gearbox. But extra you can see horizontal line I have drawn, that is representing NEM. Okay, so one additional line over here I have shown. Why? Because NEM, that is motor RPM, is greater than the maximum speed of a gearbox. Okay, now how we need to draw this diagram? So since we know that the power is transmitted from an electric motor to our gearbox, right? So we need to start from this point. So motor shaft, that is having a, how much RPM? NEM. So starting from this point and directly come to the center of the input shaft. Remember, we need to come directly to the center of this input shaft. So center of this input shaft would be where? So in between N3 and N4 speed at this point. Okay, now from this point of input shaft you can see two lines are drawn, which is representing a number of speed steps available in this particular stage, and a distance between these two lines it represents, that is it is 3. Okay, so this is represents the distance between the adjacent speed steps. From this point of intermediate shaft we can clearly see again two lines are drawn, so these two rays are representing two speed steps, and a distance between them represents the x2 value. Okay guys, now this is a speed diagram, but from this speed diagram we need to draw a ray diagram. So how we can draw? So see this diagram carefully. Since we know that the rays are drawn for the lowest RPM of a last shaft, which means from this speed diagram can I say that this lowest RPM of a last shaft, which means this line. Okay, so starting from a input, that is a motor shaft, going to the input point and directly going where? To the output shaft, which is representing a minimum RPM. So this is going to represent the ray diagram. Okay, so which I have shown over here. So you can see this is a ray diagram. Okay, so this is how we need to draw. Now next step is to construct a kinematic gearing diagram for a gearbox by calculating the number of teeth on a different gears. Okay, now let us see the comparison between the structural diagram and a speed diagram. So structural diagram I have shown over here. You can see this is our structural diagram and this is a speed diagram. Both these diagrams we have discussed in detail. Okay, so let us see the parameters to differentiate. Now the first parameter is a vertical line. So in a structural diagram, you can clearly see that three vertical lines are there, which means n plus 1, two stages are there and three vertical lines. So the structural diagram contains n plus 1 vertical lines for an input shaft, intermediate shaft and output shaft. Whereas a speed diagram contains one vertical line for electric motor. So you can see this line, and n plus 1 vertical lines for an input, intermediate and output shaft, which means in this case we can say in total n plus 2 lines are present in a speed diagram. Then comes the next parameter, horizontal line is how much. So in a structural diagram contains the number of horizontal lines equal to the number of spindle speed steps, that is z is equal to horizontal line. Whatever is the speed steps available is equal to the horizontal line in case of a structural diagram, whereas we know in a speed diagram it contains the number of horizontal lines required for locating all the spindle speeds as well as the electric motor speed. Okay, now next point is based on a spindle speeds, that is n. The structural diagram does not give the information about a spindle speed, whereas a speed diagram gives all the spindle speeds available. Next point is based on a range ratio. Now this range ratio is denoted by Rn. So we can clearly know that a structural diagram does not give the range ratio of a spindle speeds, whereas a speed diagram gives the range ratio of the spindle speeds. Okay, so you can clearly see that the range ratio would be log Rn to the base 10 starting from the n minimum to n maximum, which is shown in this diagram. Geometric progression ratio. The structural diagram does not give the geometric progression ratio detail, whereas a speed diagram gives this geometric progression ratio, which means by using this speed diagram, if phi is not given, so we can even calculate the value of phi. So you will get a clear idea of these last 3 points when we solve the numericals. Okay, last point, electric motor speed. So the structural diagram again does not show the electric motor speed, whereas the speed diagram shows the electric motor speed. Okay, so this is the difference between a structural diagram and a speed diagram. I hope guys that you are clear that how we need to draw a ray diagram, speed diagram and a structural diagram. In our next session, we will start to solve the numericals of this chapter. So till then, stay tuned and thank you all.